Good evening. Today we are going to see the different steps which are involved in design of slab base and design of gusseted base. So first we will see design steps that is for slab base. So first step we have bearing pressure allowed. Now this is given in IS. Maximum value is given zero point 0.6 FCK, but generally this value is taken as 0.45 FCK. This is same for both slab base and gusseted base. Then area required for base plate, same formula we have for both. Factorial load upon permissible bearing pressure, which is 0.45 FCK. Then decide the dimensions of base plate. And now for these dimensions, in slab base, we are going to provide. So we have this as column, and this is base plate. And this base plate we are going to provide at by providing distances A and B beyond the column. Now, mostly in slab base, we are going to provide these values as the same. We are going to provide A equal to B, and due to that one, your cantilever portion will be same, and whatever bending moment will be developed in this cantilever portion will be same, and due to this your slab base becomes economical. So to become an economical slab base or base plate, we should have A equal to B. Then actual bearing pressure, so factorial load upon area of base plate provide, and this value should be less than 0.45 FCK because we have allowable bearing pressure as 0.45 FCK. Then we have fifth thickness of plate. Now direct formula is given in IS code, but we will see how this formula was derived. So we have TS be the thickness of the base plate, and then we will get MD is equal to 1.2 ZE upon gamma MO. Now this value actually is taken by IS code, and by using this value, they have derived the formula. Now, actually, if we will see, then we have for rectangular plate it is 1.5, but this is taken as 1.2 ZE upon gamma MO. Then we have 1.5 ZE is 1 into T square by 6. So we are going to consider that the base plate, and in this one we are going to consider this width as 1 and thickness as T. And from this we will get I is equal to BT cube BD cube by 6. So BD cube by 6. And then we have Y is equal to T by 2. And if we will find I by Y value, then we will get it as I is 1 into T cube by 6, and Y we have cube by 12, and Y is T by 2. And from this we will get 1 into T square by 6, and that value we have put over here of ZE. Now we have this will be base plate, and A and B are the dimension of base plate beyond the column. Now if we will take bending moment at XX, then we are going to get this value for XX, and this value we have WA square by 2. Now if we will take bending moment about this YY, then you will get this value that is equal to WB square by 2. Now this WB square have effect on the stresses which are developed on this side due to WA square by 2. And IS code has considered Poisson's ratio as 0.3, and this much coefficient is considered in MYY, and that value is subtracted from MXX, and therefore we will consider M net equal to WA square by 2 minus 0.3 WB square by 2. This is considered as Poisson's ratio as 0.3, and that value we are going to deduct from WA square by 2 due for net. And then we are going to equate this. So we have value of moment of resistance, we have 1, and this is bending moment, and we should have MR or MD should be greater than or equal to M net. And then equating these two values, so this we will get, actually if we will see, we have this value that is equal to WA square minus 0.3 B square upon 2 W we have taken outside. And then equating these two, so we have this 1.2 into 1 into t square by 6 gamma mo fy, and from this we are going to get this value that is of ts. So now this is considered as ts. So if we will solve this, then we are going to get this as 2, 6 and 6.2. And then if we will solve this, then you will get it as ts square, that is equal to w in bracket a square minus 0.3 b square divided by 0.4 into fy into gamma m. And then if we will solve this, then we are going to get ts, that is equal to root of w a square minus 0.3 b square 2.5 we will get into gamma mo upon fy. 2.5 we have 1 upon 0.4 is 10 by 4, and that is 2.5. And we have this formula for thickness of slab base that is given in IS code, but how it comes, that we have from this. And this value should be greater than thickness of flange. And then we have last connection between column and base plate. Generally, welding is preferred. If you will go for belting, then you require connecting angles for slab base and column. Then second, we have gusseted base. So now if we will go to this steps, then first step we have same, second step also we have same. Third step, now when we will go for gusseted base, we have to provide gusset angles and gusset plates. Now you can see this. So we have this as gusset angles. So column, then gusset plate, and then gusset angle. These we have to provide for deciding the dimensions. Now length of gusset plate, gusset base plate required, that we have uh, depth of column plus 2 into side of gusset angle plus 2 into thickness of gusset plate. So this will be my total length of the length, minimum length required. So this I can say as L. This is required for this. And then we can have width required, that is equal to area required upon length, and this we can say as length provided. And length we are going to provide a round up from this step, that is last step. Then knowing width we are going to provide, that is dimension of the gusseted plate. And then we have actual bearing pressure, again same factorial load upon area of gusseted base plate provided. Then less than 0.45 fck. Then we have thickness of the gusseted base plate. Then we have let T be the thickness required. Then same we have MD is 1.2 ZEFI upon gamma MO, and then that is 1.2 1 into T square by 6 into Fy upon gamma MO. Now in this we have to find bending moment at XX, and then we have to calculate value of bending moment. So we will get value of bending moment in this WA square by 2, and then we are going to equate. So this is bending moment. So this is one, that is MD, and this is second bending moment. And then we are going to equate these two. And by equating these two, we are going to get value of TS. And whatever value of thickness of gusseted base plate required, that thickness we are going to get from this equation. From here, we are going to get value of T. And then we to get thickness of this gusseted place, we have to deduct the thickness of this angle, which is gusseted angle, and that we have done over here, and that value should be greater than TF. And then last we have connection between column and gusseted base plate. So generally bolted connection being used for this gusseted base plate. So this is all about the steps which are related with your gusseted base plate and slab base plate. So today we will stop here only. Thank you.